Okay, now we'll try to solve a numerical with what is called as UDL, uniformly distributed load. Guys, what is this? It's a truck. Guys, I think you might have seen, it's not a unseen picture. I think everybody would have seen this on the roads. They're carrying very big steel rolls for sheet metal. Okay. Now, suppose if somebody is trying to convert this as a numerical for giving it to UG students, so what would they convert? So they would actually consider this as a beam. They would have considered this as support, one support. Here they would have considered this as one more support, something like this. Usually a simply supported beam. And then each of this steel rolls maybe around 5,000 kg something. 5,000 kg is like 50 kilonewton. So 50 kilonewton. So you would write it as 50 kilonewton. You would write it as 50 kilonewton. And here you would write it as 50 kilonewton. Here you would write it as 50 kilonewton. And here maybe the engine everything maybe around something around 2 kilonewton. Sorry, 20 kilonewton, which is actually 2000 kg. Okay. Engine, cabin, everything is actually 2 kilonewton based on this. These are actually point loads. This is how you actually, now we are not actually, you may feel like we never come across this type of triangles, this type of rollers. So we are trying to reduce a complex problem to a simple problem, so that it becomes easy for us to go ahead for basic calculations. So these could be called as the hand calculations. Okay. So this could be called as hand calculations here. So before you actually try out calculating the chassis, I think engineers should be able to do these calculations, basic calculations. Now instead of these rollers, somebody has actually put sheets. Now these are not rolled into these blocks. Maybe somebody has actually put a sheet here. Sheets of sheet metal like here. Sheet metal over this. Okay. Then how would you show the load? Here we showed it as point loads. Then how would you show this load? Now this sheet, now this whole sheet is like 20,000 kgs, 20 tons. This is actually equal to 20 tons. 20 tons is how many kgs? So 20,000 kgs. So 20,000 kgs is approximately equal to 20,000 kg force is approximately equal to 200 kilonewton. So 200 kilonewton. Sorry, right now? Yeah. So 200 kilonewton. Now, how do you actually write this? How do you actually, Center of mass. So that means you will consider all this and actually put it as a single load here. You can solve like this. Guys, is it right? I'm not asking you to solve a problem. I'm trying to make you analyze this. So, if somebody wants to carry huge amount of sheets placed here like this. What he's saying is, now to analyze whether it is safe or not, all this 20 tons of force, which is actually equal to 200 kilonewtons, has to be placed at this point. Will this actually solve the problem? Is it right? What he's doing is right? Hey, say yes or no. No. Why do you think it's no? Because there's load falling here, there's load falling here, there's load falling here. So you can't put all these loads at this point. Okay. So in this case, we try to show it as something like this. At the starting point here, we try to show something like this. Some people try to do it. Suppose if they are doing manually like this, they do it here. Some people also try to do it like this. small arrows here. Okay. Now imagine that this length is actually equal to 10 meters. I'm not going by the length of the vehicles. Okay, I'm simply taking some random values. So this is actually 10 meters. Okay. So for all of this 10 meters, the load is how much? 20. For 1 meter, what will be the load? For full 10 meters, it is 200 kilonewton. For 1 meter, what will be the load? 20. So what will they write is, they show it like this, 20 kilonewton for every meter. In the numericals, they would show it like this. If there are steel sheets spread like this over 10 meters, and the total load is 20 newtons, which is approximately 200 kilonewtons, then they would write it as 20 kilonewton for every meter, and they would show the length as 10 meters. And here they would show it as 6 meters, here they would show it as 4 meters, something like this. Okay? And here they would show maybe like 3 meters or something. Okay? So 3 meters. So this is how UDL is handled. So as I said, all of the sheets is actually loading at every point here. So you can't actually put all this UDL at a single point and solve it. It will be difficult. So you actually show it like this. Now you are very comfortable in trying to solve single point loads, force into distance. But here, if you do this, how do you solve it? It becomes difficult. So for that, there is one way of solving it. So for moments, because for taking moments, it is force into distance. Okay, so we can solve it in one way. So I will explain you how we can do it. So somebody guess what I'm drawing? Can somebody guess what I'm drawing? What is this? Somebody was saying, yeah, what is this? Seesaw. Okay. I put one box here. Now to balance this, I put one box onto the left hand side here. One box here, I put a box onto the right hand side here. It's balanced. I put a box here. I put a box here, it is balanced. Now, I give a challenge that I put this box ABC one above the other, but still balance it. How would you put it? Will you actually put this ABC like this? So will you put A and B over C, or C and B over A, or will you put, so which is better? So put this ABC like this, so that means A and B over C, otherwise put this so keep A wherever it is, put this B and C over A, otherwise you actually put this B at the same place, bring A over and C over. So which do you think is right? 1, 2, 3, which is right? 1. So guys, I'm not asking anything. Okay, people are saying 1, so that means you're bringing it near. Suppose if there so should I move this A and C over B? Will it work? Or should I move this A and B over C like this? Or should I move this C and B over A? Which is better? So the third one is keep B wherever it is. Move this A here and C here. Is this better? Or these two are better? People are laughing. That means, guys, what is the answer? So 3 is better. So you feel 3 is better because you know that if you try to move, imagine 3 children sitting here. 3 children sitting here. Okay. Imagine, okay, of course, imagine children getting over one over the other, maybe she's sitting on a shoulder. If all this B and C comes to A, they're coming near, it will not balance out. And if you again move this A and B over C, it will lead to more moment here. It will again go down because their moments are more. So it is better bring C here and bring A here. That will actually balance out. So what I'm actually trying to show is that here you had UDL, here you had UDL which balances this load. So for taking moments, whatever is said we have to do. So that means this whole, so suppose if each of this is actually 1 kilonewton, if each of this is 1 kilonewton, 1 kilonewton, 1 kilonewton, 1 kilonewton, then you take full 3 kilonewtons and place it at the center of the UDL. Place it at the center of UDL. It is only for calculating moment. This is only for calculating moment. Calculating moment, okay. I think some people directly replace this UDL with the point load. Don't do that. Because for calculating moment, you see, as you come here, force into distance you want to do now, then you can't add up this. For UDL you can add up. For UDL you can add up because now as I come from here to here, for every 1 meter, so much gets added? For every 1 meter, how much gets added? 20 kilonewton gets added. For every 1 meter, 20. For one more 20. For one more meter, 40. For one more meter, 60. Like this, it gets added. Or it may actually get deducted depending upon the convention. But for moments, you need this force into distance, no? So for that, what you can do is you can take the UDL onto the right side. So you take the sum of this UDL, place it at the center, then you see how much is the UDL multiplied by the distance. So something like this. So UDL has to be replaced by a point load for calculating the moments. And for shear force, you can simply keep adding. So I think this problem with this concept, we'll try to solve it in the next class. And most of the people, I will say, when it comes to point load, most of the people will do it correct. But when it comes to UDL, most of the people are not able to understand. Okay? So I don't know what is the problem. Please solve few problems that will make your understanding better. Okay?